control, uniform heating is vital for operational parameters for both for quality and battery life. Maintaining uniform room temperature for the consistent room temperature for the heating tools. We should also maintain the proper air gas ratio in all the combustion chambers to avoid carbon deposits and even heating profiles. We should avoid overheating, which damages the refractory air silica rings. Avoid underheating results in undercooking, affecting power quality and BF productivity. So, monitoring requirement plays important role in the reduction of combustion power. Pushing operations is a very critical parameters. Monitoring pushing force provide a real-time insight into the oven conditions and power quality. We should always monitor pushing force to avoid oven failure. High pushing resistance is due to the carbon deposits which affect the wall of the ovens. High pushing force is due to the bulging and cracks in the oven chamber, which increases the pushing force resistance during the time of pushing. High pushing force due to improper cooking also affect the mechanical stress to the refractory structure. Oven walls in the refractory care. The refractory walls of oven battery are its most critical structural asset. Wall failure causes battery life productions and production capacity. Preventing cracks and bulging. Proper operational discipline in heating controls, charging and pushing is vital for preventing refractory damage. Regular inspection and crack monitoring. Ceramic welding for repairs, repairing cracks in the silica refractory without requiring any shutdown. Grinding is used for the surface restoration, where the restore eroded wall surfaces by mortar through grinding application. Wall failure is a major cause of battery life production. Once wall collapses, the affected organ is permanently lost and the adjacent organs are at risk. Coke oven doors and sealing. Coke oven door is a critical environment and operation parameter. Gas leakage from the door is both safety hazards and major source of polluting emission. We should practice regular routines of all the oven's charging rates and the seal replacement of the oven door on schedule basis. Alignment check of oven doors, pushing, sealing failures. Gas and pressure control. Maintaining correct gas pressure within the coke oven system is important for both safety and environmental performance. Maintaining slight positive pressure inside the oven to prevent air ingress, which could cause combustion inside the oven chamber and damage the refractory structure. Proper gas collecting main to be maintained for oven pressure balance and gas recovery efficiency. Carbon and deposits control. Emissions control, preventing leaks from the doors, lid and optics, minimize emission. Strict standard continuous monitoring of hazard gases to be followed. Leak sources to be controlled. Leaks from the door, oven doors, charging lids and the optic to be the emission compliance. Advanced battery life extension techniques like hot repair, ceramic or graniting is done for wall repairs without any shutdown. For cold repair, plant shutdown is taken for the repairs of battery restoration. End wall repair, restoration of end walls to be maintained to strengthen structural integrity. Digital monitoring, data-driven diagnostics and maintenance for productive care. Combining hot and cold repair with digital diagnostic maximize the battery service life. What are the common causes of battery damage? High pushing force. Excessive pushing force during pushing accelerate wall tear and cracking. Poor heating control, uneven or improper cooking causes the thermal stress and wall damage. Improper cold blend increases cooking pressure, stressing oven walls. Neglecting during maintenance allow minor problems to escalate. Sudden cooling, rapid temperature drop causes thermal stress and structural cracking. What are the best practices in summary? Uniform meetings should be followed. The pushing force should be controlled. Tight sealings of all the doors and lids to be maintained. Maintenance schedule to be followed. Monitor oven walls condition. Regularly inspected and reported oven wall health and integrity. We should train operators. Regularly training ensures consistent adherence to best practices. Best practice summary, I think we have discussed here. What are the keys to long battery life? Operational disciplines to be followed. We should train the operators. We should control pushing and consistent procedures to be followed. Regular training to execute critical tasks such as making informed meeting, control pushing forces, and ensuring tight sealing of doors and lids. To maintain quality, schedule repairs to be there, digital and data-driven monitoring to be done, like digital monitoring and diagnostic helps operators to detect early walls cracks by shifting to a precise data-driven approach that identifies the structural issues before leading to further damage. Like for charging, we are using the load cell. For pushing, we are using the pressure amperage meter. For temperature monitoring system, we are using thermocouple, temperature sensor and temperature sensor. For gas and pressure monitoring, you are using the gas analyzer, meter and pressure transmitter. And advanced digital systems like SCADA or others is used for the real-time dashboard of entire battery. So lastly, in the conclusion, by maintaining the operational disciplines and maintenance quality, we will extend the forthcoming battery life. Thank you. So if you have any questions, you can please ask.
जी आपके बैटरी कितनी बैटरी है फिल्म में?
फिल्म में सर हमारे अभी टोटल 6 बैटरी बैटरी 1, 2, 3, 4 and 5 और एक आपका न्यू बैटरी 6।
अच्छा, ये ओल्ड बैटरी कितने इयर्स का है?
और बैटरी सर बैटरी टाइप सबसे पुराना है, अमाउंट आपका अभी 30 इयर्स हो जा रहा है।
इसमें गोल्ड रिपेयर कितना लिए?
अभी सर वो आपका गोल्ड रिपेयर आपका अभी सर हमारा बैटरी 4 बीम में चल रहा है। बैटरी 4 बीम में हम लोग 44 अभी हम लोग का गोल्ड रिपेयर हो रहा है।
नहीं, मेरा मतलब है कि आपका जो सबसे लंबा बैटरी चला है उसमें कितना गोल्ड रिपेयर लिए? 1 लिए, 2 लिए, मतलब 30 इयर्स वाले कितना बोले?
30 इयर्स सर, 30 इयर्स।
कौन सा बैटरी?
बैटरी 5।
बैटरी 5। तो बैटरी 5 में गोल्ड रिपेयर कितना लिए या एंटीवर्टिकल रिपेयर कितना लिए?
सर अभी वो बीच में हम लोग उसको रिपेयर करा रहे थे। जैसे अभी हमारा 5A अभी ऐसा कंप्लीट शटडाउन है। 5B में हम लोग 20 ओवन हम लोग रिपेयर कराए, फुल वॉल रिपेयर।
तो अभी कितना मतलब?
अभी हमारा सर ओनली एक सब बैटरी चल रहा है, 40 ओवन चल रहा है बैटरी टाइम।
टोटल अभी जो 6 बैटरीज का पुशिंग मतलब आपका PRI कितना है?
PRI सर हम लोग अभी टोटल बैटरी नहीं है, बैटरी 5 का
टोटल पुशिंग कितना PRI क्या चल रहा है?
हमारा सर अभी टोटल डे का 356 पुशिंग हो रहा है।
कितना में?
हमारा बाकी 3 बैटरी में सर 75 ओवन से, बैटरी 4 में 80 ओवन से, बाकी 5 नंबर में अभी 40 ओवन से।
One thing is there, we have come for this operating committee. We should try to bring the presentation so that if something special we are doing. Best operational practices, these are the normal practices which every coke maker should do. This is a kind of thing which you can write in a manual, or you can write in a unit training manual or something where you give training to people. Most of us are generally coke making experts.
Okay.
So you should bring something new which you are doing as per your operational practices. What are the things which you have done which you normally don't do? Those kind of practices which maybe other plants are not following, and you think that you are doing it well to bring battery to a longer life. If that kind of thing is there, then I think it will be a better sharing of the things in this forum. So if it is there, you can tell, you don't need to give the presentation, you can tell normally also that if you have done something for the batteries. Any practice which you think is very good for the batteries.
So like we have done IV changing procedure in battery 4B. So what we've done in IV changing, sir, normally we used to feed the coke gas, CO gas in the course of changing IV. So in battery 4 we have some battery, so there is a interconnection bar. We normally use another method without heating air. In CO gas, either ramshack or coaxial, wherever we change the IV, the process we have changed a little bit, sir. We have just diverted the course of CO gas. Like if you are changing IV in the ramp side, so we just put the ramp side totally off gas by just controlling the gas flow through coke side and through G-cement to the exhauster. In that case, we just avoid a lot of emissions in the atmosphere of CO gas, plus the safety issues are also in check.
That means you need to say, you want to say that you, in a double G-cement kind of battery,
Yes,
you are making it single G-cement at the time of changing of the IV. You are closing all the IVs of one G-cement and then you are going for changing.
Yes,
That's what
How much time it takes?
it will take almost 1 hour, 45 to 1 hour.
We are doing it with both the hydraulic and operation condition, only 22 or 25 minutes. So if you want to see our IV changing protocol, you can see.
Okay, sir.
Any other special challenges which you are facing, which you would like to discuss in this forum? Like yesterday the RNS team explained some special situations they handled over the past few years. So any such thing or anything, any special challenge which you would like to discuss with the house, which you want to overcome but not finding a solution?
So one challenge we normally face. One challenges we normally face is during rainy season when you're using loading core from the bunker, At that time the coal discharge from the bunker is not proper, so we used to keep poking to get the coal. At time if someone didn't take care of the proper closing of wing gate, then the coal may fall down. So that is one of the main thing we problem face during the rains.
You don't have a pneumatic program system or a air blast?
Pneumatic systems we don't have in all the batteries. Like in battery 5 we don't have pneumatic system. In battery 1 also we don't have pneumatic system. Only battery 2, 3 and 4.
थैंक यू। अब मैं टीम JSW विजयनगर को आमंत्रित करना चाहूँगा।
Good morning everyone, respected delegates and colleagues. I am Amit Kumar. I am from JSW Steel Limited, Vijayanagar, Bellary, Karnataka. Today I will be presenting my practical experience of restoration of Coke battery 8. So this is our overview of Coke plant, Coke 1, 2 demolished and Coke 3, 4 and 5 in running condition. I belong to the Coke 4 and Coke 4 consists of 4 batteries. Each battery have 72 ovens. So this is the process overview of the Coke making plant. Coke 4 types of recovery plant and byproduct plant, and it started in 2010, 1.91 metric ton per year. So our problem statement is battery faces several issues like flame from SP cap, flame from Coke side, heavy flame from SP cap, heavy flame from oven lids, oven top condition from the process side, heavy flame behind the guard plate and flame from the anchor system, heavy flame from lintel, bucket stay and guard plate got burned due to heavy flame. So due to heavy flames, out of 72 ovens, 13 ovens had taken out from the operation for due to heavy damage. So this is our business plan according to affected between 21 April to 6 June 2022 due to unavailability of the 13 oven and execution of the remedial action plan. So these empty ovens lead to the reduction in the oven ability, loss of the production, increased maintenance cost and safety concern due to flame and the gas leakage. So these are the root cause analysis. So first our root cause analysis is heavy flame from the anchorage system, flame from the door bottom, heavy flame from lintel area and flame from the inclined flue zones. And oven door latch outside, door setting problem and oven door not properly down. Damaged inclined flue zone, flame from the guard plate bottom, damage from the brick lining and damaged refractory. Flame from oven door after charging, heavy gassing from the door, water leakage from the upper truck. Overhead civil slab damaged. So the condition of the all empty ovens assessed and remedial action plan has been made in the 3 phases. In the first phase, all empty ovens with the normal guard plate and bucket stay were rectified. In phase 2, 3 ovens identified that the guard plates and bucket stay are damaged. So we plan in phase 2 to 875, 876 and in third phase 877 guide plate and bucket stay was changed. So these are the activity carried out during the first phase. So 10 out of the 13 ovens were successfully charged within 1 week. So these are the activity carried out during the first phase: frame pointing, lintel pasting, inclined flow, brick lining and guard plate grinding. And sole pointing, some ovens guard plate was down below 110 mm, so door setting problem was observed. So end bricks has been changed, reduced height, and so door setting problem reduced. This is the oven door maintenance, J-bolt tightening and the CTR spring during the first phase. And in the second phase, 875, 876 bucket stay and guard plate damage, so we planning to change these ovens bucket stay and guard plates. So adjacent oven we maintain the temperature of 1200 and empty ovens we maintain the temperature of 1150 and the adjacent oven maintain the 1250, 1280 degree temperature and 1250 degree temperature. So under 872 and 878 ovens were under charge 3.8 meter and pushed after 28 or 29 CPD, and oven number 871 and 79 were charged with the normal cake height and pushed in 26 CPD. Our CPD is 24 hours. So in phase 3, 877 bucket stay and guard plate changing plan. Same thing we followed. Oven number 874 and 79 were under charge and pushed out in 28 to 29 hours, and oven number 873 charged with the normal cake height and pushed in the 26 CPD. So this activity carried out during the guard plate changing. Pusher side first we erection the support wall and then dummy wall erection. Pusher side bucket stay locking and door frame removal, old bucket stay removal, old guard plate removal and bucket stay cutting point. 875 heating wall face after removing of guard plate and bucket stay 876 and 877. 3 ovens critical, that guard plate and bucket stay were damaged. So after guard plate removing, so we saw the heating valve face level was not even, so we first leveling the surface of the heating valve, then new guard plate erection done and new bucket stay erection done. New bucket stay welding from the bottom side and CTR spring loaded, auxiliary spring tightening done. So manual. So after first charging 875, we faced that due to abnormality in temperature and roughness over the oven sole, oven number 875 got sticked, and the entire oven was manually racking done and scooped using the pusher cars, because adjacent ovens are empty, so we cannot forcefully push the ovens. So this activity we carried out during the oven racking. So after empty oven 875, again we taken for the ceramic welding and from pusher side and fork side. So after 1 month, all oven are available and our execution remedial action plan done, and availability of the all oven 72 oven available for the next within 1 month. So these are the pushing in the charging timeline and empty ovens. Detailed timeline and the maintenance activity job. These are the refractory job during 72 ovens during 1 month of cycle period, and this is the before and this is the after post maintenance. No flame observed from the oven lid and XP caps, and this is also the post maintenance. No flame is observed from the oven door frame, guard plate and lintel and inclined flow joint. So our execution challenge was a limited shutdown time and maintenance safety during the hot conditions, ensuring quality repair within the plant shutdown and coordination among the multiple teams. From this project we learned that small leakage should never be ignored. Last time our one sir last day said the small leakage हमें हमेशा इग्नोर कभी नहीं करना चाहिए और फ्लेम तुरंत ही अरेस्ट करना चाहिए, नहीं तो ये बड़ा क्रिटिकल, जैसे हमारे कंडीशन में हुआ, पहले एक ओवन में आया, 2 ओवन में आया, हमने थोड़ा इग्नोर किया और एक ही टाइम में हमें 13 ओवन में सडन फ्लेम ज़्यादा आने लगा, तो इसलिए कभी और प्रिवेंटिव प्लांट मेंटेनेंस इज मोर इफेक्टिव देन द रिपेयर रिएक्टिव रिपेयर और रिपीटेटिव फेलियर्स ऑलवेज इंडिकेट्स द डीपर रूट कॉजेस. Team coordination play a major role in success. And so last point I would say, restoration is not about fixing damage, it is about eliminating the reason it repeats. Thank you.
Which agency did the job for you?
Yes sir.
Which agency did all these repair jobs for you?
Time duration.
Which agency?
Foswell sir. Foswell and our JSW team sir did all the jobs.
And why did all these damages happen? I mean, suddenly, because I went to Bellary probably 3-4 years back, it was quite good. 25 last year, these kind of damages happened. Why it happened? What was the basic cause?
Sir, basic cause was actually sir trough leakage sir. Due to trough leakage sir, and main cause was trough leakage and हमने क्या किया, थोड़ा डोर चेंजिंग में डिले किया क्योंकि हमारा सिविल का ओवरहेड जो सरफेस था वो डैमेज हुआ सर, तो डोर चेंजिंग हमने 3 मंथ से किया नहीं, वो धीरे धीरे फ्लेम में एक्यूमुलेशन होते होते गार्ड प्लेट ये सब डैमेज होना स्टार्ट हुआ सर.
But door change I think is not the root cause, क्योंकि मेरा अपना एक्सपीरियंस है कि हम लोग 3 साल में भी डोर चेंज किए हैं, नो गैसिंग नो बर्निंग. सो बर्निंग गैसिंग का रूट कॉज कुछ और.
ये हमारा क्या वो वाटर लीकेज थोड़ा ज़्यादा हुआ सर, वो ट्रफ से सर डैमेज.
वाटर सील ट्रफ होता है, एपी का वाटर सील ट्रफ सब जो
ट्रफ से वो कोक साइड वाटर ज़्यादा स्टार्ट हुआ सर वाटर.
उससे क्या
जो है आपका
So what I found there, the thing was that the anchorage was ignored for more than many years, you can say.
Yeah.
Systematic repair was not being carried out. If it is required to be done for 6 month का cycle हो या 3 महीने का cycle हो, tie rod checking, what is the condition of the elongation of tie rod, where it is reaching punctured. It starts from there and then it comes to a glazing stage. So that was my finding based on which that you were saying.
तो गैरेज मेजरमेंट का क्या फ्रीक्वेंसी है आपका?
DTR measurement monthly once, sir, and 6 months once DTR thickness measurement, sir.
ये रेगुलेशन जो है हमारा जो है किसी दिन बंद नहीं होता है. अगर मान लीजिए कि ये मेजरमेंट वाइज करते हैं और आपका रेगुलेशन जो है चलता रहता है जिसमें भी कोई कमी रहता है.
No, sir, actually क्या problem है, sir, water is the main enemy of the silica bricks, sir. Due to continuous overflow of the trough, because it is in pH condition, sir. The rope sealing between guard plate and silica brick has wear out and their gap has been created. From there, we are shooting up the flames.
और ये डोर क्लीनिंग का मैकेनिज्म मतलब मैकेनिकली है या मैनुअली है आपका?
No, sir, mechanically है, sir. Door cleaner है, sir.
तो जो फ्लेम आ रहा है वो आपका जो स्टार्ट हुआ उस समय जो जिस डोर में फ्लेम आ रहा था उस डोर को या तो उसका क्लीनिंग प्रॉपर नहीं था या फिर आपका जो है उसका डोर में प्रॉब्लम था.
सर एक्चुअली सर वो हमारा जब डोर डाउन करते थे तो पूरा चारों लाइन जैसे हमारे पास होता है वो पूरा सेट नहीं हो रहा था सही से. तो हमारा हमने बाद में रूट कॉज फाइंड किया क्यों नहीं हो रहा है. तो हमने देखा वो सोल ब्रिक्स था थोड़ा हाइट ओवन का फ्रेम जो था थोड़ा डाउन हुआ था सर. डाउन होने से फिर हमने वो सोल ब्रिक्स को ही थोड़ा सा टेपर करके थोड़ा साइज 20 में 5 करके ये किया. ये थोड़ा हमें लेट पता चला सर. इसकी वजह से और थोड़ा ये हमारा फ्रेम जो डैमेज हुआ सर बक स्टे डैमेज हो गया फ्लेम ज़्यादा आने से सर. और हमने उसी टाइम पे सर वो मिडिल लीड भी ओपन करना स्टार्ट किया. उसकी वजह से टाई रॉड में भी थोड़ा प्रॉब्लम आया सर. तो थोड़ा
I think your batteries are stainless steel design, right?
Yes, sir.
Yes sir.
When end bricks, jam bricks are fire glaze rather than silica.
No, sir, jump bricks are this one.
Fire
Fireplace.
Not fire clay, sir. This aluminum bricks, sir.
Aluminum, right?
Yeah,
Not
yeah.
silica, not silica.
Not silica.
Not
So
silica.
is there any gap happening between the jam brick and the silica? Is there any gap happening between flash plate and jam brick?
Yes.
Yes sir. 875, 873 ovens we found out there.
So those things are to be carefully checked.
Yes,
Because those are the things where it actually originates. Those gaps should not come.
Due to production force, we are not taking for the maintenance, sir. Continuously water falling from the troughs. Because we are using dust car, sir. We are not using CGT car, sir.
Okay, fine. Thank you.
I have some points.
Hello.
So, are you measuring the vertical flue pressure?
Yes sir.
Are you measuring the flue top pressure?
Low temperature sir.
Flue top pressure.
हाँ sir.
What is the top pressure maintaining the heating flues?
In GF batteries, we are maintaining around 0.2.
Are you measuring during this period?
Yes, sir.
Because what I found you need to either recheck because the root cause which you have mentioned that may have some linkage with this, but I think you need to relook with the vertical top pressure and heating, the end flue temperature, all those things. You need to relook because if the problem may repeat after 2 or 3 years,
Yes.
so the water can be the immediate cause, but the underlying causes are still not find out. You need to find out what is the vertical top pressure and flue temperatures in these ovens that may have some linkages with boxer failure and door failures. We have seen this type of issues.
In endovertical, it was not maintained, sir, due to this one water leakage. Water was entering with dust in end verticals, 27th and 28th vertical flow. The ports has been jammed. In that 2 vertical flows only, pressure not maintained, sir. VTP not maintained.
That is the reason actually.
Okay.
If you are not maintaining pressure, your carbon deposit is getting burnt out.
Okay.
Once carbon is burnt out, then the low burn and all these things are happening. So this is the root cause. The root cause is not the water. Water will after effective water. Thanks. Thanks.
There are many causes. Okay. There are many reasons, many which comes before, which comes after. It is a matter to discuss. I think the light team they know very well. इतना चीज बताया गया ना. All these things we people in cell have encountered. All these things. Flash light coming down, door light coming down, doors not sitting, lifting, all these things. I have faced in batch number 3. सो ये कुछ नया चीज नहीं दिखा है, ये सारे चीज हम लोग सेल में पेश कर चुके हैं। एक रीजन नहीं होता है, आप देखिएगा हंड्रेड्स ऑफ रीजन उनका
15 ईयर में फर्स्ट टाइम हमने ऐसा फेस किया था।
ये हर एक प्लांट को एक चीज इसको फेस करना पड़ता है, और एक बार फेस करने के बाद में जो लर्निंग होता है वो लर्निंग का आउटपुट है अभी बोकारो कोकोवन। हर जगह बोकारो का कोकोवन इस कंडीशन में है, इट इज बिकॉज ऑफ द लर्निंग दैट यू आर गॉट एंड नागपुर had. Exactly same thing if we finished our days of Nagpur 2008-9 to 2015-16. Around 78 years we have encountered that through life, that through Naukila, everywhere. It's nothing new. And उसी से ही लर्निंग होता है, that generation दोबारा वो स्टेज को बैक करना नहीं चाहता है, और वो लर्निंग से फिर नेक्स्ट फेज जो शुरू होता है वो नेक्स्ट फेज तो अभी जो बोकारो को सब देख रहे हैं, इट इज द रिजल्ट ऑफ इट। सो कोई एक पॉइंट नहीं है, हम अगर गिनाएंगे तो 100 पॉइंट गिना देंगे आपका वो प्रॉब्लम है। आपको देखने के बाद कुछ प्लान को जाने की जरूरत नहीं है, यही बता देगा क्या ऑल ऑफ फ्रेश
अभी हम लोग इनोवेशन किया सर, फर्दर गार्ड प्लेट डाउन नहीं होना बोल के एक लॉकिंग सिस्टम बनाया सर। यस सर,
ठीक है, ये सब करना पड़ता है, को चलाना है।
हाँ
बट फिर जब आप लोग करके मीटिंग करके जब आइए तब फिर आपको लर्निंग हो जाएगी कि क्या किए थे, सो दैट सो ऑल द थिंग्स हम लोग फेस कर सकते हैं।
ये सर हम लोग का 2011 से लेकर के अभी 2026 में अभी 15 इयर्स में हम लोग का 11 या 12 टायर्स जो है वो हम लोग चेंज किए हैं सिंस बैटरीज ऑपरेशन 11 और 12 ओनली। टायर टूटना तो हम लोग सोचते हैं कि टायर नहीं टूटेगा, कोरोना पीरियड में जो है हम लोग ऑक्सीजन ले रखे थे तो उसमें 2 टूटा था और बाकी जो है रहने की हो गई।
थैंक यू सर, थैंक यू। अब मैं टाटा स्टील खमरिया की टीम को आमंत्रित करता हूं।
Good morning. This is the agenda which I will describe in the next slide. This is the basic information what the role play in the blast furnace. This is I have already described in my previous session. Our capacity and our plant is the heat recovery coke plant. This is the just process flow of our plant. In our plant, there is we have 2 cutters for sizing the coke because our blast furnace is the mini blast furnace. So there the MPS is the major factor. We cannot take the large size of coke for our blast furnace. So that's why we have the system the coke cutting for maintaining the MPS below 48 for our blast furnace. This is just a process of heat recovery coke plant. The basic feature is that we have no need to extra fuel or extra energy source because this helium is sufficient for heating, and our process is operating in the negative suction, so it is environment friendly and slight flexibility. High pressure pool we can use in our process because the wall pressure is slightly flexible for our design of coke plant. This is the basic design of our non-recovery coke plant.
where the air control is from the two point, one is primary, that is from the doctor, and another is secondary from the soul. And the two point where we control our air for our process, and the left side is the design of our batteries. This is the basic principle we follow for our landing and operational activities. This is some achievement, gradually increase our production and gradually increase the uses of indigenous coal, mainly West Bokaro, and gradually decrease the uses of hard coking coal. And last, our hard coking coal use is 48%, and followed by 36% SS and 16% indigenous. This is the mainly battery maintenance arrangement. The spray is the LTR, CTR, and PTR, and this is the maintenance time frame in a year, and every year we also, before monsoon, we grouting the oven top to ensure that no water ingress from the top of the oven. This is the last year we check our oven from third parties and find that there is no soil deterioration. Only the pusher side and coke side slight deterioration is there, and we have planned this year also ceramic welding will be done. Only for 7 oven, where the both side, particularly 7 oven, whose the both side, coke side and pusher side, both side slightly deteriorate in the aluminum brick and cast iron plate and aluminum brick gap. There is some deterioration, which will be ceramic welding will be done in this year. In the year of 17-18, FY 17-18, there will face a major problem, the top load falling due to bracket board failure. So it leads the frequent, in a year 5 to 6 times top load falling scenario happened during pushing time. So root cause was the bracket board failure. So we rectify it to develop in-house development of the bracket on the block stack and the J-hook arrangement on the top. If the door is failure from the board, it will be hanged from by the ground. And there is duct repairing procedure. There is two procedures we follow for the small radar spot and the big radar spot. The small radar spot, when we find the radar spot in the flow duct, repaired it from the local point of view. From the top, we fill up the gap by the castable and cover the top. And if they are the big and its life is 5 to 6 years, and total development. This is the signing case. I will be discussed from.
गुड मॉर्निंग सर. सर साइनिंग केस में हम लोग क्या है कि एक मेन होल डेवलप किए हैं. जो हमारा जो चिमनी टेम्पर है सर, ये हमारा चिमनी टेम्पर है. तो चिमनी टेम्पर के पास में हम लोगों ने मेन होल डेवलप, उसके नीचे जो डेब्रिज जमा हो जाता था, टेम्पर का जो फूट जाता था, उसको हम लोग प्रॉपर सील किए. ये सर जैसे ये हमारा मेन होल बनाए, उसके बाद डेब्रिज क्लीन किए, फुल सील किए. उससे क्या है कि हमारा इनलेट टेम्परेचर इंक्रीज हुआ और साथ में हमारा पावर जनरेशन भी इंक्रीज हुआ. हमारा बैटरी सक्सेस इंक्रीज हुआ. क्या है कि ओपन टेम्परेचर रहता है, तो हम आता था जिसके और अभी 3 mm इंक्रीज हुआ है. थैंक यू.
Sorry, extremely sorry. We are from Durgapur Steel Plant. I am Abhigyan Banerjee, AGM Performance. And presenting with me is Shri Shomit Dattorai. He is GM and HOD COR. Today we are going to present a very specific case study that we had just in the month of April. We had to repair our battery 5-spoke quenching car track and a section of that, and for that period some of our ovens went out of circulation. How we managed the issue, we are going to show in this presentation. I have taken this from Google Earth. This is showing our battery number 5. We have 2 blocks, 39 ovens in each block. Oven dimension is as given here. GC main in both sides, pusher and coke side. You can see in the blue shaded portion, that is the portion of the quenching car track line that we needed to repair, and also the quenching tower of battery number 5. And beyond that, not in this picture, is the rebuilding site of our COB4. And just beyond the quenching tower, the track line doesn't exist, and when the battery number 4 will come up, it will be joined. Why we had to do this repair is that this battery was rebuilt in 2016. It's 10-year-old battery. Right from the start, there was some mismatch in the alignment, and it resulted in some of the coke car was rolling. Sometimes it rolled during in that region. So we were having some little issues in our OIS cross battery interlocking. But slowly over the years, this problem aggravated due to loss of sub-base integrity, and of late we were having many electrical breakdowns like power collector outage or breakage, and also one mechanical breakdown, bearing failure also took place. So we had to repair this this area, but we were not getting a sufficient window to do that. That was achieved. That window was opportunity presented itself in the month of April, where from the period of 18th to 20th April, where all the 3 blast furnaces of Durgapur Steel Plant were shut down for some repair of common facilities. So that period we took the opportunity to do this repair, and we had we would not be concentrating on the repair part, but we will be concentrating on only the precautions that we followed before, during and after to avoid the damage to ovens and to prevent stickers. The basic plan was, on the first day there would be dismantling of rail and fasteners of the affected portion, then dismantling of damaged concrete, build-up of reinforcement if required, and then grouting with Shrincom 30. And after curing for 24 to 36 hours, 24 was the basic minimum, but we cured for 36 hours. Then after that, fitting of rails and fasteners, and resumption of open operations from day 3. So we had this opportunity to plan.
Before explaining all this, just tell a brief of how coke car track line, quenching car track line is built over there. I mean, what is the arrangement? Because normally in all Cookman batteries, the quenching car track line is on ground level.
Yes.
Your case is different. If you have some pictures, you can show that. So that people, house can know what are the complications.
Yeah, our coke car track line is not at ground level. It is at a raised level, at a level of 1.5 meters almost from ground level. And in battery number 5, after rebuilding, we did some modification because our sleepers were concrete in that, and that was the modification that we did in battery number 5. But the problem of level mismatch, it remained, and in that portion, and it was aggravated by the place being near to quenching tower and breeze and steam and whatnot. So coming back to the things that we will be concentrating on the plans that we did before, during and after the job, and we had the opportunity to plan this repair, and it is unlike the Vizag experience that they had, because they had no notice period. We also had some similar incident like Vizag, when one of our coal conveyor galleries, it was damaged last year. So, but not like this. So, and it is very important, if a section of your ovens are going down and you are planning to, it is very important to plan it, and also talk to the experts. We had many meetings. We consulted with Bhaskar sir and also experts in coke ovens from various plants, and the jobs that we, and one thing I'd like to I have used screenshots from videos to make this presentation make this presentation size small. So I have the videos. If anyone needs it, I can give you later. So what are the actions that we planned before the job? Under firing changeover, we had to change it over anyway to coke oven gas from mixed gas. Normally this battery runs in mixed gas, but we did it to coke oven gas as well as all the batteries we had to change over to CO gas because of blast furnaces were going down, and all the valves that motorized split valves that are not operated regularly. We didn't want that when we had to go and it was not operating then, so we checked it beforehand. And as I was saying that we have two blocks, A block and B block, and the GC main, there is a balancing line. Normally the valve is closed and it is blanked, so we de-blanked the balancing line and also eased the valve because we had an inkling that we might need to open that valve so that to balance the lean A block GC main from the gas in GC main B. Wire rods were cut for insertion into underfiring orifices, and two special doors at coke batteries for measuring the sole pressure. So we changed it, changed the doors in. We put the special door in 506 coke side and 511 ram side in the affected area, so that we could measure the sole pressure throughout this period. And we normally the cooking time is 21.5 hours. We gradually reduced the schedule and increased the cooking time to 24 hours, so that we apprehended the graphite, the ovens might go out of run, so it is easier to take care of it. So during the job, for the last charging of the affected during the job, for prevention, we did notching from progressive notching in our IPs, double-sided GC main positions open or closed. One side after only 7 hours, so that the more time when on both side. It's given MWC, we had to increase it to a maximum of 18 MWC. Oven source pressure measurement started at 20 hours. In the ovens, in which special doors were given, and it continued till pushing at a frequency of every 4 hours. Sealing of doors both sides and leveling into a ceramic blanket in all the affected ovens. And we gave schedules in such a manner that the charging in the rest of the 24 ovens of A block was spaced evenly. 8 ovens charged for shift so that Jacimate does not become too lean. Changes in exhauster sections, speed valve position and Jacimate pressure was made accordingly. And opening of balancing line was not needed in our case. You can see some of the pictures that during the job. This table shows the different actions that we took on the hydraulic raising side. You can see that in A block we increased it gradually to 18 mmWc to maintain Jacimate butterfly position, and also we had to reduce suction accordingly and then increase it after the job was over. And open source pressure in bottom side, it was positive throughout the job. Regarding the heating part, we decreased the orifice so that from 40 mm in the orifice boxes. Of isolation blocks were done on reaching 22 hours. Temperature was taken at flue numbers 2, 5, 6, 14, 15, 23, 24 and 27 in the affected walls every 4 hours. Target temperature was 1100 to 1150 with greater than 950 degrees centigrade in end flues. When all the ovens reached above 20 hours, generally 50% isolation valves were closed and rest 50 were kept 5/8 open. Swapping of the valves closed to 5/8 open and vice versa was done every 4 hours. Care was taken for controlling the underfire butterfly valve, though the closing of the valves were planned in such a manner that it cut across both the reversals, so that the controlling of butterfly in both the reversals is better. Wire insertion was done according to the bonding checking and the temperature that came. This was the rough plan that we made, and more or less we stuck to it. With only minor modifications taken from the temperature that came. Temperature in the wall 515, which was shared between regular oven and affected oven, was kept at around 1180. And this is the temperature that what we failed to apprehend, that in the first day you could see in night shift I have given temperature in after 24 hours. In the first day temperature fell because some ovens which became ready, we closed the gas box, then the adjacent ovens which were still in their cooking, they leached out. The ovens were more or less ready and we were confident that soil pressure was made positively, so we could increase. The ovens were pushed, all the ovens were pushed in run, and in a period of 77 hours, almost was